Welcome. In this video, we're going to look at solving quadratic equations using square roots. So this really isn't a new tool. It's a tool that you've been using to solve equations in general. It's just using our inverse operations to isolate our variable, just like we've been doing so far. So we want to keep in mind that our order of operations, right? We are going to do any grouping symbols first, then any exponents, and those exponents are also with your roots. So that's kind of your top tier of things that you're doing aside from those grouping symbols. So it's going to be the last thing you undo. Just like when you solve equation, if you have a multiplication and subtraction, you're going to undo the subtraction first, then undo the multiplication. Your exponents or roots are going to be the last thing you do. So the first thing we want to focus on is, this says isolate the x squared, and then we're just using the inverse operation as squaring, that's square rooting, to get the variable by itself. So like I said, it's the same thing that we've been doing. Just keep in mind that if you're introducing that square root, we want to include the positive, the principal root, and its opposite. So if we have a simple equation like this, x squared equals 169, the only thing we have to do here is introduce the square root. So then we get x equals the principal or the opposite. The square root of 169 is 13. Okay, a little more work on this next one. We have this additional plus 7, so we want to get that x squared by itself first, right? Because that's the last thing we're undoing. So we're going to subtract 7. We get 0 equals x squared. Oh, so x equals 0, and I'm going to say plus or minus 0 because 0 is neither positive nor negative. Okay, so let's look at when we're going to use the square root method. We're going to use the square root method with any quadratic without an x term. So you know our quadratics in standard form are ax squared plus bx plus c. That x term that I'm talking about is this guy. If we have that, we can't just directly take square roots, because then what happens to that x? I can't isolate my x if there is an x squared and an x. So anytime you have that x squared but no x term, we can solve just using our inverse operations. So first thing, we identify what operations we have. We're multiplying and squaring. So we're going to undo multiplication before we undo squaring. So we're going to divide by 81. Well, I'm just going to leave that as 25 over 81. You might notice something about those numbers. They are both perfect squares. So when we take our square root here, x is just going to be equal to the square root of 25, which is 5, and the square root of 81, which is 9, and it could be the principal or opposite, so we're going to include that plus or minus because we are the ones who introduced that square root, right? So if you square a negative number, it's also positive. Okay, let's try another one here. We have some multiplication, subtraction, exponents. So we're undoing those in our reverse order. So we're going to undo the thing we do last. 4, and then divide. So we get x squared equals, that simplifies to 1/4. Then take your square root. So x is going to be equal to plus or minus, square root of 1 is 1, square root of 4 is 2. Okay, so we're just using our inverse operations. We just have that additional inverse operation that will happen right at the very end that we are going to introduce that square root. Subtract 49. X squared equals negative 49. Take the square root. What times itself is negative 49? Uh-oh. No real solution. All right, our radicand here needs to be positive to have a real solution. Since it's negative, there's no real solution. Okay, here we're going to add 45. So x squared equals 45. Introduce our square root, so x equals plus or minus the square root of 45. This one's a little different. 45 is not a perfect square, so we're going to go back to our simplifying radicals and think about how can I simplify this 45. 45 is 5 times 9. 9 is 3 times 3, pair of 3s, so we get plus or minus 3 root left over 5. So don't forget all those tools for simplifying radicals. If you get something that's not a perfect square, you can still look for perfect square factors. Okay, just a couple more examples here. If we look at this guy here, I have some multiplication and some addition. Undo the addition first. Negative 3x squared equals negative 120. Okay, multiplication is less powerful than exponents, so we're going to undo that multiplication next. X squared equals 40. Then we can undo our square. We're introducing that square root, so we want to keep the principal and its opposite. 40 is 10 times 4. Oh, 4 is a perfect square. 10 is 2 and 5, so we'll just stick with 10. Square root of 4 is 2, root 10. Okay, so we're just using those inverse operations to get our variable by itself. Let's try one more here. This would be a great one to try on your own and then check your answer. Add 30 to both sides. 5x squared equals 30. Divide by 5. X squared equals 6. Introduce your square root. 6 is 2 and 3. It has no perfect square factors. So x is just plus or minus the square root of 6. Okay, so we're still just using those inverse operations, reverse order to isolate our variable. We've just added in one additional inverse operation, and that's that square rooting. So if you have something that you are squaring, to undo that, we are square rooting. Let's look at a couple that look a little different because we have some grouping symbols. So we still want to isolate the thing we're squaring first. But on this one here, this thing's already isolated. So once it's isolated, we're going to take the square root, okay? Because this is the next operation on my list to undo. So that subtraction is grouped. So that's going to be the last thing we undo. But now what happens is I have x minus 6 equals plus or minus 6. We have to include the positive or the principal or the opposite. When you end up with something that looks like this, split it up into the two equations. X minus 6 could be 6, or x minus 6 could be negative 6, so that you can get those two solutions. If I add 6 here, I get x equals 12. If I add 6 here, I get x equals 0. If you're not convinced, always go back and check. If I take 12 minus 6, I get 6. 6 squared is 36. It works. If I put 0 in there, 0 minus 6 is negative 6. Negative 6 squared is 36. So both of those solutions work. Make sure that once you get to this step, break it up into those two different equations. Okay, same thing here. We have this whole thing is being squared. So this is the next thing I need to undo. Introduce that square root. I'll get x plus 3 equals 12. X plus 3 equals negative 12. Solve those individually. I get x equals 9, and here I get x equals negative 15. So we get those two solutions that both work for our problem. You can plug it back in to check. 9 plus 3 is 12. 12 squared is 144. Negative 15 plus 3 is negative 12. Negative 12 squared is 144. So check and make sure your answers work back in your initial equation. These two have little extra things going wrong, so you're still going to use your inverse operations, reverse order. This whole thing is being squared, so I still want to get rid of this 2 first. Right? Division is less powerful than, or multiplication is less powerful than exponents. So then we get x plus 2 squared equals 100. Now this squared is the next thing I would deal with. So we get x plus 2 equals 10. X plus 2 equals negative 10, because both of those square to be 100. Subtract 2, we get x equals 8. Subtract 2, we get x equals negative 12. So still doing the same thing, we just have that additional step after the fact. We want to make sure that we split it up into its principal and opposite so that when we're solving those, we get the two different values. Same thing here, divide by 2. I get x plus 2 squared equals 50. Okay, this one's a little different. 50 is not a perfect square, so when I go to take the square root, I'm going to get a radical as my answer, and that's okay. It just actually makes it a little simpler with our solving, because here I get the square root of 50, which is 10 times 5. 10 is 5 times 2. Pair of 5, so we'll get plus or minus 5 left over 2, root 2 equals x plus 2. Well, I'm not actually going to add or subtract the 2 to that, so I can just leave it here and subtract 2 from both sides, and we'll get x equals negative 2 plus or minus 5 root 2. That still gives us two values. It's just since they're not exact values, I could find those values by typing in my calculator, right? If I take 5 root 2 minus 2, and negative 5 root 2 minus 2. Right, those are the two actual values, but you can see that those are not nice. So we always put the number up front. Otherwise, it looks like it could be inside your radical there. So negative 2 plus or minus 5 root 2. Okay, that's all I have for you for today. Thank you so much for watching.